All right, so I think this is recording. Let's take a look at these three problems. They're asking us to find the domain and range for each equation, for each relation. Um, so when we're finding the domain, we can find it algebraically by considering two things. Um, we we have to avoid division by zero. And second, we have to avoid taking the square root or any even root of a negative number. And we're going to be saying that over and over and over again pretty much throughout the year. So in number 9, I have an absolute value function. And the domain for this function is all real numbers because I don't have a variable in a denominator, so I don't have to worry about division by zero, and I don't have any square roots, so I don't have to worry about taking an even root, a square root of a negative number. So my default answer is always going to be all real numbers. It's always all real numbers excluding any values of x that cause division by zero and excluding any values of x that would cause us to take the square root or a fourth root or a sixth root or any even root of a negative number. Now, for the range, I'm going to show you how to do that on a graphing calculator on a website here in just a second. The domain for number 10 is again going to be all real numbers because once again we do not have a variable in a denominator and we don't have any square roots or fourth roots. So by default the domain is a set of all real numbers. Now in number 11 I don't have to worry about division by zero, but I do have to worry about taking the square root of a negative number. This 2x minus 5 has to be a value that's greater than or equal to 0. So if we solve this for x, as long as we're bigger than 5/2, as long as we're bigger than 2.5, then we're okay. If we're smaller than that, like say 0, 2 times 0 is 0, and 0 minus 5 is a negative 5. And within the set of real numbers, we cannot take the square root of a negative number. So the domain for number 11 is from 5/2 out to infinity. Now, let's come back to number 9. With experience, you're going to be able to, especially after the next skill packet, to sketch the graph of the absolute value of x plus 2 without a graphing calculator. The graph of the absolute value of x, you are probably familiar with it. It looks like a V, and we call this point the vertex, just like if it were a parabola, and y equals the absolute value of x has its vertex here at the origin. This plus 2 is what we're going to see as a vertical transformation of this graph that's going to lift this graph up 2 units. So I'm going to show you on the graphing calculator that the graph of this number 9 looks like a V, and the y-intercept here is 2. And all of the points on this graph are all above that 2, except for that y-intercept, which is right at 2. Because remember, the range is the set of y values. So I'm going to illustrate to you that the graph is going to tell us that the range is 2 to infinity. So I have that already pulled up. All right. So this y sub 9, this is just my notation for problem number 9. If I toggle that, you can see the graph is a V shape. It has been lifted up 2 units from the origin. The graph of the absolute value of x looks like that. And if you add 2, that lifts that whole graph up 2 units. So this entire graph, every single one of these y coordinates all have a value that is bigger than 2. Look at, I could extend this table forever, and all of these y values are going to be 2 or larger. Okay, so that's how. Here's our answers for number 9. Now, let's take a look at number 10. Look how similar it is to number 9. What we're going to learn is we already know that the absolute value of x is a V shape centered at the origin with its vertex at the origin. And this negative sign is going to take the opposite of these y values. Right now, all these y values are positive, and that negative sign is going to flip this graph so that it's opening downward. You've seen that when you studied parabolas, that when you had a negative x squared, it opened downward. Well, when you have a negative absolute value of x, it opens downward. And that plus 2, just like it did over here, it's going to lift this graph up 2 units. But this time, my graph is opening downward. So from the graph, I'll be able to look at that and say, hey, the range for a minimum value, you're coming up from negative infinity. And you're coming up to this point on the y-axis, which has a y-coordinate of 2. Let's illustrate that to show you that I was correct in how I did that. There it is, the absolute value. Now, here is the absolute value of x centered at the origin. That negative sign in front of there, we said that would make it open downward. And now the plus 2 is going to shift that down 2 units. So you can see that the graph here in number 10 and this graph that I just was showing you how to get to those steps are the same. How come it's not turned there? That one's red, and this one is blue. All right, so I think you can see that. All right, let's take a look then. So there's our domain for number 10 and our range for number 10. And right now, you don't have probably the experience. Some of you may be able to reason it out, but you probably don't have the skill set yet to graph this on your own. So therefore, you're going to have to use this graphing calculator. And from given the picture, you should be able to find the range. Now that you're expected to be able to do. Now, this square root of 2x minus 5, it's a little more complicated. The graph of a square root function, we know that it has a domain that's 0 or positive. That's the square root of x. This minus 5 is actually a shift to the right 5 units. So this whole graph gets shifted to the right 5 units. And then, believe it or not, this 2 actually shrinks the graph horizontally, and it takes half of 5 to where right here, 5 over 2, and it's going to open like this. So, but you do not have the experience yet, I do not think, to do this without a graphing calculator. But you can key it down on a graphing calculator. You're definitely capable of typing this in and then looking at this graph and getting information from this graph. To look at this graph and to say, well, the y values are up and down. There's no portion of this graph that's below the x-axis here. And we can even make a table to play around with different values. So you can see right now these x's are all to the left of 2.5. They don't have a corresponding y value. These x's are not in the domain. Our domain was 5 halves or bigger, 2.5 or bigger. So we're going to have to come in and key in 2.5, which is 5 halves. Hey, that's giving me a 0. And then key in a 3. Key in a 3.8. Key in a 10. Key in a 12. And what do you notice? Well, you notice that all of these y values are positive. 0 are positive. The first one that associated with 2.5 was 0. And then after that, as x increased, y also increased. So our range for this, looking at this picture here in the green, and looking at that table that I just made for you in the graphing calculator, it's 0 to infinity. Now, these ranges are going to be more difficult. And we're not going to, however, put as much emphasis on finding the range as finding the domain. The domain is going to be primarily our focus, and the range, yes, over time, we will learn to read it from a graph primarily, or both graphing techniques and algebraic techniques. It's not quite as clear-cut all of the time to find the range as it is the domain. The domain will be able to find it algebraically, and these two rules that the domain is a set of all real numbers, excluding any values that cause division by 0, excluding any values that cause us to take the square root of a negative number. That's going to be pretty uniform. That's going to be standard. We're always going to be able to rely on that. And through repeated practice, we'll get very good at finding the domain. The range is more of a challenge, and like I say, we will not have as much emphasis on the range. So I hope this helps, and I will talk to you later. Bye.